Netlabs hub where we are going to configure this network to achieve convergence network whereby voice and data is on the same network. As you can see, this is the switch, this is the router 2800 series, then these are the instructions. The voice VLAN or the voice network is going to work on 192.168.10.0/24. Then the data VLAN is on the 172.16.10.0/24. So VLAN 10 is going to be data, then VLAN 20 is going to be voice. VLAN 20 voice. Let's create VLAN on the switch. To create VLAN on the switch, VLAN 10 name data exit VLAN 20 name voice. Then after creating the VLAN, we assign the switch ports, whereby this is switch port number 2, this is 3, then 4. You can just say that this one it goes to gig 0 because all this traffic depend on this link, so this link should be with higher bandwidth. So we are going to assign interfaces, interface range, first Ethernet 0, 1, 2, 5, switch port access VLAN 10, VLAN 10, switch port access VLAN 20, switch port access VLAN, switch port voice access switch port voice VLAN. What is the voice VLAN? That is the VLAN 20. So without putting the word voice, it will not be, these computers will not be able to check, to differentiate. So let's check running configuration, show running config. You can see that VLAN 1 is both in 10 and 20, 10 and 20, all the first VLAN. When we show VLANs, show VLAN, you can see VLAN 10 data is here, is having first Ethernet 0, 1 up to 4, then voice. So let's configure. I'm done configuring the, let me give the host name LTK switch 1. So after creating the VLAN, now I'm going to configure the trunk port. The trunk port to route traffic between the voice and the data VLAN. So to configure the trunk port, I'm going to go into global configuration mode, interface gigabit 0/2, describe the interface, trunk port, after trunk port, that is it. So after here, no shutdown. No shutdown is used to bring up the interface. After there, switch port mode, trunk, switch port, trunk allowed. Now we are forcing our trunk port to allowed and 10 and 20. Allowed VLAN 10, 20. So this section here, without the word VLAN, you cannot do this. And right, show interface brief. So as you can see, interface gigabit, the description is here. This is the trunk port you can see here. So that is it. Then to save, we write memory or use copy, run, startup, configuration 5. That is it. So I have created VLANs on the switch. Configure this port as trunk port. Now the one that has remained, I'm going to create two pools, two DHCP pools on this router. This router is going to serve as a call manager for these phones to communicate. And these are the specified numbers for these phones. Our phone number 1 shall be with the 1010, then phone number 2, it will bear 1020, then the last phone, it will be 1030. So these are the instructions that VLAN 20, that's voice DHCP is going to work on this. So my phones should get IP address from this pool. Then this command, without this, the DHCP pool for phones shall not work. So let me start with the configuring DHCP pool for the phones. IP DHCP pool voice underscore VLAN 10 VLAN 20 default, that is 192.168.10.1, then network 192.168.10.0/, that is it. DNS, we can give DNS to be just of the normal, that is Google. Then without this command it will not work. Option 150, then IP 192.168.10. This command is used to link or to connect the phone to the call manager. This is the gateway that we've given as this is it here. It will help the phone to get the DHCP server. So after that, we finish our configuration. Our DHCP pool is created. We can see show running config. This is it. This is it, as you can see here. So let me proceed to DHCP pool for data. IP DHCP pool data underscore VLAN 10 default 172.16.10.1. So I have created a pool, given the default router, specified the network, the default router address, specified the network. Now the DNS, we can also give it domain name, netlabs.com. Exit. After exit, I'm going to exclude to define the IP addresses that my computers and phones pick. So IP DHCP exclude. Let me start with the voice VLAN 192.168. My phones shall pick IP addresses from 100, from 1 or from above 100, that's 101. And then the computers, I want them to get IP address from 61. That is it. We make this router to be the DHCP server by enabling this command service DHCP. Then done. Let me verify. Let me verify if So it has failed because haven't finished configuring this. Now there is the Inter-VLAN part of it. It is not working here. So it is difficult for it to pass traffic, and then this interface is down, as you can see. Traffic cannot pass through this switch. So config terminal interface first Ethernet 0/0 description main interface no shutdown. The moment I just give it no shutdown, you can see now it's up, but still it won't get IP address. I'm sure. Let's check. Still it has not worked. So let me configure Inter-VLAN routing on this router. Interface first Ethernet 0/0. We go to the main interface. Then we unshut the interface. Then we give it 10. 10 is the VLAN ID for data. So encapsulation dot 10 IP address. That is it. Description VLAN 10 data. And then this is what I'm configuring Inter-VLAN routing. That is 800 IEEE 802.1q. So let me move to the voice VLAN 20 encapsulation dot 20 IP address, the first IP address from that LAN, that is 192.168. After there, no shutdown, we describe this VLAN 20 voice. Copy, run, startup. Let me give the identity to my router. So this is my call manager. So that is it. Now I have configured the trunk, created VLANs, assigned switch ports, moved to the router, configured the DHCP server. Then, as you can see, I have configured what we call Inter-VLAN routing. First Ethernet, under the main first Ethernet 0/0, there is 0/0.10, 0/0.20, and the assigned IP address respectively. So let me check. You see, now it has gotten the IP address. Let's try to ping the call manager. Ping what? Ping the gateway. The gateway, it can reach the gateway. That is it. So it's working. This one. I remember I conditioned my computer to get IP address from this pool starting from 61. So that is it, just as I have configured on the server. So the remaining part is now configuring the call manager for this aspect, for this phone, so that this phone can get numbers and ping each other here. So these are the steps to configure the Cisco router as a call manager for Cisco IP phones. We start by telephone service. We enable the telephone service. After the telephone service, after the telephone service, we define the maximum number of directory numbers, these two commands, and then the maximum number of IP phones. So the max, it is just 3, then max phones is just 3. This one shows that the maximum directory numbers is 3, that is, we have 3 phones. Then as you can see, these are 3 phones. Then after here, auto assign 1, 2, 3, then IP source once the voice VLAN, that's 192.168.10.1 port 2000. Go and research about this command. What does it work? So this command works by linking the call manager to respective IP phones through this particular IP address, that's the gateway, and the port, that's 2000. So after here, we assign each phone with its respective directory number. So we start with the phone number 1. The moment I put phone number 1, then that directory number 1 to 1 is up. Then number, they say that we use 1010. Then if phone directory number 2, number 1020, then number 3, 1030, 1030. So you see, my phone has registered. Let me save. So that is how we configure the Cisco router as call manager to make sure that these IP phones functions well. So as we can check, the Cisco IP phones have received already the IP address and the IP address from the dedicated pool, then the gateway, then the number. As you can see, this has received 1030, so just change here. Because it is auto assigned, there is no arrangement on how it gets this number. So this one 1020, then this one 1010. So let me ping 1030 from 1010. Let it be put there. So I'm calling 1010. As you can see, this is 1010. I'm calling 1030 from 1010. So I put this number here, 1030. The moment I start ringing to this phone, this button, it will start blinking. So you can see my phones is working. My phones are working. I can still call this to this and still it will work. So 10. You see from here it is from 10. So that is it. This is how Cisco phone. Let me hang up. So This is it. We can ping this to this, this to this. So this is how a converged network is created. So the steps, let me give you the steps here. Steps to configure converged network in Cisco Packet Tracer. So these are the steps. Step 1. Step 1, cable the network. Cable the network as shown. Step 2, configure VLANs 10 and 20 for voice and data. Step 3, assign switchports or interfaces on both VLANs. So both VLANs 10 and 20 should use the same interfaces. That's 1 to 5. The switchport should access VLAN 10 for data, VLAN 10 for data, and then VLAN 20 for voice. After assigning switchports to VLAN, then create DHCP pools for both VLANs, data pool and the voice pool. Stage 5. After configuring the pools, having created the VLANs, assign the switch ports, configure the port facing the router from the switch. The port facing the router from the switch, this is gig 0/2. Configure trunk port. And I said trunk port, its function is to route traffic from multiple VLANs or from 2 different VLANs to the router. So it allows communication between VLANs. So that is it. Configure trunk port. That's why port facing the router from the switch. As you can see, this is the port. Then 6, configure call manager and assign phone numbers. 7, confirm reachability. So these are the steps. These are the steps used to configure the converged network. So this computer on VLAN 10, that is data. That is data, then this is it, voice. So this is the converged network. Let me verify. Ping this computer to this computer. Let me give this admin, then user 2. So user 2 can ping. Let me confirm this computer. It has gotten 172.16.10.62. So I stand here, then ping 172.16.10.62. It works. It works. This phone can ping this phone as early as I had shown you. So I can repeat. You see it has gotten 1030 to 1010. You see it is ringing. This is the phone that I'm calling. You can see the moment I receive them. That is it. If you feel this lab has helped you greatly, please feel free to subscribe to Netlabs Hub on YouTube to keep on watching, keep on learning. Next video, I'm going to do a complex stuff than this. Thank you.